So I'm combining 4.5 and 4.6 kind of into one because they're basically the same thing with some minor discrepancies. So I'm just going to do them together. For the first one here, this is something you've seen before or should have seen before. So if we've got 5 sprinters in a race, we want to figure out what's the number of ways they could come in first, second, third. So to get the gold medal, silver medal, bronze medal. So if we look at this, let's say this is first place. This is going to be second place. This is going to be third. We want to look at, if I've got 5 sprinters, how many options do I have for first place? Well, any one of those 5 sprinters could come in first. So I've got 5 options for who could come in first. So second's 4 because one of them is in first, and then third. If I want the total number of ways, I'm going to multiply each of these together. So 5 times 4 gives you 20. 20 times 3 is 60. So this is how I've showed it to kind of do it the long way.
The long way?
Yeah. It's not super long. The quick way to do something like this is just saying, I've got 5 people to pick from. It's a permutation, and I want 3 of them. So this is the way that I've shown in the past couple sections, is being able to do this. This is the past. This is what we did in the past. In this case, does the order matter? So if a person comes in first or if they come in third, does it make a difference?
It does.
It does. If you went to the Olympics and you got a gold medal instead of a bronze medal, it makes a huge difference. So it does matter if you're put in first or if you're in last. It does make a difference. So this is an example of a permutation, so this is what you've seen in the past, of 5 objects, and I take 3 at a time. So here's where the 5 and the 3 come from. I have 5 objects, and I want 3 of them. So that's just where it comes from.
So this is the whole answer?
This is the whole answer, yep.
So like after I get the 60, I should do 5?
No, once you get the 60, you're done. So there's 2 ways you can solve it. You can either solve it this way, which eventually if I ask for if I have, I don't know, 200 people and I want to know how can they be arranged from 1st till 50th, it'll take a lot to write it out.
Yeah.
So that's why this way is just quicker, because you can put this in the calculator. You just put 5, there's a P on the calculator, I think it's above the times symbol, if I remember correctly. If you do shift times, do you get the P?
Yeah.
Yeah. So then you can just type that in there.
Like 5, shift times G. Yes.
Yep. So there you go. So now let's imagine we're going to change the situation a little bit. Instead of doing who comes in first, second, third, now I'm going to tell you that the fastest 3 are going to be on a relay team. So I no longer care who's first, second, third. I want to know who's going to be on the team. So we can kind of picture this as I've got 5 people. 3 of them are going to get Ys for yes, we're going to get select you, and 2 of them are going to say no. So if we looked at the method we just talked about, I've got 5 people total, because I'm going to arrange Y, 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 N, N, N. So 5 people. This would say the first 3 I'm going to say yes to, the last 2 no. And then looking at combinations of letters, I've got 5 letters total. So 5 factorial over, I've got 3 Ys. So it's going to be 3 factorial over 2 N's. Or with 2 N's, so it's going to be like this.
You have to answer because he will get the money for the graduation fee.
Yeah.
Hello?
So if you plug that in the calculator, you'd get 10.
This one?
Yep. So 5 factorial over 3 factorial and a 2 factorial.
Thank you.
Mm-hmm. So in this case, does the order matter? So if a person comes in first or third, does it make a difference for them?
Which case is it?
In the one we're dealing with here. So it says the fastest 3 qualify for a relay team. So it doesn't matter if you were in first or third in this case?
No, it's only two, right?
Yeah. So if you're first, you're on the team. If you're third, you're on the team.
Yeah.
So in this case, the order doesn't matter in terms of how you're selected. Obviously, if you're fourth, it matters because you're not selected. But in terms of who I pick, it doesn't matter. So this one is now a combination, and here's the difference between them. So before was permutation with the P, now it's going to be a combination. So in this case, it's a combination of 5. So I have 5 people, and I want 3. So on the calculator, if I wanted to solve this, I would just put 5, and now we use a C instead of a P.
So how would you see?
So C is when order does not matter. P is when the order matters.
No, I mean if I want to do this in calculator, 5, 3, 3,
How would you put that in the calculator? There's a button right beside where you found the P.
so it's
I think the dividing sign.
yeah,
Yeah, so above the dividing sign you have this NCR. So that's how you'd use this one. So we previously talked about permutations, now we can talk about combinations. So a combination is a group of objects where the order does not matter. So for instance, if you're wanting to play football outside and you're picking teams to be on one team or the other, it doesn't matter if you're selected first or last, you're still going to be on the team. It might still affect your ego if you're picked last, but it doesn't affect if you're on the team. So for example, 2 objects A and B have one combination, because if order doesn't matter, this is going to be the same as this. If I go AB, that's the same as BA. So if you're picking partners for a project, it doesn't matter who I pick first and second, you'll still be a part of that group. So there's 2 ways that you can write this out, or it's noted. So it's NCR is the general equation for this. The second way it can be written is brackets like this with no dividing sign. It's just like this. This one's not as common, at least from what I've seen. I've more seen this one. But it's the exact same. And don't worry so much about the formula. There's supposed to be a formula here. You don't need to worry about that. So you'd write this as N choose R. Questions on this? Does that make sense? Okay. So now let's look at something like this. So we've got 7 people, 3 are males, 4 are females. And we want to make a committee of 3 people from these amount of people. So in a committee is just like a group of people that get together and make decisions or talk about something. So in this case, does my order matter? Does the order matter? Does it matter who I pick first or second or third? No. So this determines if we use the C or the P. So in this one, order does not matter. So since it does not matter, we're going to use the permutation. Yeah. So we'll use NCR. And in this case, the number of people I'm picking from is 7. And I want 3. So you can plug this in your calculator. Give it a try. Yeah, see what you get. $35. Good. Yep, that's what I got. So that's how straightforward it is. All you need to figure out, does the order matter? If it does, use the P. If it doesn't, use the C. So how about part B? We want how many different committees of 3 people can be formed if the first person is the chairman, the second is the treasurer, and the third is the secretary. So would order matter in this case?
Yes.
Yeah, because the first person has a specific job. The second person has a specific job. So this one, yeah. So order matters. So if the order matters, now I need to use the permutation. So 7p3.
So how did you get that?
Because I've got 7 people that I'm picking from.
So this is the same question.
Yeah, and when you're doing this number, so n should always be bigger than or equal to r. Otherwise you'll get an error. So this first number always has to be the bigger number.
210.
210, yeah. Make sense so far?
Yeah.
Not too bad. We're gonna, once we get into these restrictions, it gets a little bit more complicated. So how many different committees of 3 people can be formed if we want to pick 1 male and 2 females? So now we're getting quite specific. This one, the order does not matter. It still doesn't because we don't have specific roles. But we want to figure out first, how many number of ways could we pick a single male and how many ways could we pick 2 females? And so what you can think about this is, we're choosing 1 male out of a group of 3 and 2 females out of a group of 4. So we're going to say, out of 3, I want to pick 1. 3 choose 1. And for this one, it's going to be 4 choose 2. So I'm picking 1 male out of 3. I'm picking 2 females out of 4. And due to the fundamental counting principle, I times these 2 things together to get the total. Mm-hmm.
So why do you use C? It doesn't matter.
The order doesn't matter, yeah.
Yeah.
18, yep. So this part, just so you can remember when you look back to your notes, so this part's for the males, and this is for females. Does that make sense?
Yeah.
Okay.
So then we must choose one male group of P.
Yeah. So this next one is where things start to get a little bit trickier. So we want at least one male on the committee. So I still am making a committee of 3 people, but I need to have at least one male. So this means I can have multiple cases. So I could first of all have a case where I've got 1 male, 2 females. Yeah, I could have 2 males, 1 female, or 3 males, 0 females. So I've got 3 cases that I can deal with.
This is another one, right? 3 female.
Yeah, so there is 3 females and 0 males, but we're told we want at least 1 male. So that one wouldn't fit the criteria. So because I've got 3 cases, it makes it slightly more difficult, but I'm just going to do this thing 3 times and then add them up. So it's just one more layer of complexity, but it's not too bad. So this one, I want 1 male with 2 females. Okay, we've picked that one already. We know this one's 18. So I'm not going to rewrite that one. We know that. Then to get 2 males, so this one's 3 males to pick from. I want 2 of them times, there's 4 females, and I want 1. And then same thing for the last one. 3 males, I want all 3 times 4 females, and I just want, or I want 0.
So it's 12.
Mm-hmm. Yep. So the total, you just add them up. So 18 plus 12 plus 1. So 18, 20, 30, 31. This is the answer. Yep. So anytime you're given at least or at most, you're going to deal with multiple cases like this.
So it doesn't matter.
Well, at least means you need to have more than, and if you have at most, like if I said at most 1 male. So at most 1 male would mean you could have 1 male or no males. So you just need to be aware of that. I'll give you a sec to jot that down.
Will you do anything the next week vacation?
Next week before the vacation?
No, after the next week.
What am I doing? Is that what you're asking?
Yeah, are we going somewhere?
For the weekend, I'll be at the sea for a little bit, but then the rest of it I'll be at home. So hopefully it'll be relaxing. Do you have plans?
I want to go to Libya.
Mm-hmm.
Like for 5 days and come back.
Nice. Do you have family there?
Yeah, of course.
Okay. Okay.
I have done with the UK.
Yeah, that's a little bit longer flight. So notes for this, don't worry about the first one because that's related to the formula which I didn't teach. So don't worry about that one. When solving problems with combinations, you might have to use the fundamental counting principle. If you don't remember the fundamental counting principle, it's from section 4.1.
I will do the notes today.
What's that?
I will do the notes today.
Okay, sounds good. And with combinations, sometimes what we did is something called direct reasoning. So that means just finding the cases that the conditions are involved. So what that means is, so like for this, here's the condition of at least one male. I solved for all the cases that solved for at least one male. So in that method that we used, we considered the cases that reflect the whatever the conditions are. So having at least one male, that meets the condition. Consider the number of combinations for each case. And then just add the results. So that's what we did. Here's all the cases that got the outcomes. We found the number for each and then added them. Another way that we could do is what's called the indirect reasoning. And I can show you with the example above what that looks like. So to do that, determine first the total number, right? Total, what did I put? Sometimes condition. Yeah, total number of combinations without any conditions. Then we'll consider only the cases that do not meet the conditions. And then determine those numbers. And then subtract. Pardon me?
We still didn't do this step.
Nope, we haven't done this method. I'm going to show you it with the one above. Because I forgot to do that. So what this looks like, so this is the cases where we considered the positives. We can also look at the negatives. So if I erase this, so I have some space here. Hi. Hi. So here's how we do the other. First, we find the total with no restrictions. So if there's no restrictions, so if I don't care about having at least one male, I've got 7 people total I'm picking from, and I want 3. So we've done this already. You've seen what this is. This is 35. Then we want to find the negative cases. So what are all the cases where I do not have at least one male? So this would be if I have 0 males, 3 females. That doesn't meet the restriction. All the others are good. So 1 male is good, 2, 3, those meet the condition. So this is the only negative case. So to solve for this, there's 3 males, right? Yeah. So 3C0 times 4C3, because I want all females. So you can plug that in the calculator. I'll just do it quickly here. This is going to give you 4. And then what I'm going to do is subtract. So to get the number of positives, I just do 35 minus 4 to give you 31, which is the same answer you should have written down from when we did the positives.
Oh, yeah.
So this is the other way. This is the one where we're doing indirectly. So indirectly, figure out the total number of combinations without any conditions. That was the 35. No restrictions. No. Consider the cases that do not meet the restrictions or conditions. So we found the negative case, find the number of combinations in that one, and then subtract. So this is indirect reasoning. The one we did before is direct. Sometimes one of them will be quicker than the other. But if you just like the direct reasoning, you can just use that one, and that's fine. If this one's too confusing, just go with the direct one. And that's this set of notes.